Dear students, welcome to the module on flowcharts. In our last module, we saw how to write algorithms for various computational problems. Like algorithm, flowchart is another problem solving technique. This module gives the introduction to flowcharts. Flowchart is one of the problem solving methods. Problem solving methods are set of techniques and graphical tools that help in providing logic for solving a problem. There are three types of problem solving techniques that are flowchart, algorithm and pseudocode. Earlier module had thrown light on algorithms. This module focuses on flowcharts. Flowcharts help to organize your thoughts and process to get the required output. So, what is a flowchart? According to Google, a diagram of the sequence of movements or actions of people or things involved in a complex system or activity. Is it not so difficult? Let us put it simple. So, what is a flowchart? It is a diagram or schematic which has special symbols to represent a process. We use flowcharts for presenting the logic for solving a problem graphically. That is, a flowchart is used to visualize the solution of a given problem. It will be read from top to bottom and left to right in order to understand the logic. These flowcharts play a significant role in programming problem and are quite helpful to understanding the logic of complicated and lengthy problems. Let me give a real world example. Suppose your mom asks you to prepare a cup of coffee. Here we have a simple flowchart that helps you prepare a cup of coffee. So what you see here is the steps used for preparing coffee. So the flowchart starts with start symbol. Then we get the input, that are the ingredients which are needed for preparing coffee, which include water, milk, sugar and coffee powder. Then we have a process. So the process include heat the water, add coffee powder, add sugar and pour, stir well, pour into cup. Following that we have coffee, which is the output. Coffee is now ready to drink. Then we have finally stop. Yeah, your coffee is now ready. Having seen an example for a flowchart for a real world problem, we are going to have an introduction on flowchart symbols. While designing the aforementioned flowchart, we have used different symbols for different purposes. When and how are these symbols used? Different symbols have different meanings. We are going to talk about what we use them for. See the different flowchart symbol. So this slide shows the symbols which are commonly used in flowchart. The first one is terminator, which we use this for stop and start. Next we have processing symbol. Following that flow lines, then decision making symbol and input and output symbol. So these symbols we have used in our previous flowchart. To start with a flowchart, we have a terminator. A terminator represents the beginning and ending of the flowchart. We use the keywords start and stop. The terminator is represented as rounded rectangle as you are seeing. See the screen for different flowchart symbols. Start and end are required for every flowchart. Next, we have a symbol for processing. In a process symbol, we place the different instructions that are required in a program. A process symbol is represented as rectangular box as you are noticing. A process involves an action. Examples for process include add, calculate, etc. Then we have an arrow or a flow line which indicates the flow of the flowchart in a specific order. Arrows are drawn from the output of one symbol to the input of another symbol. There is a symbol in flowchart which represents decision making. This symbol lets us to choose a different flow based on a specific condition. We may also want to repeat something for a number of times. In such cases, flow lines are used. An arrow or flow line can be drawn as shown on the screen. Next symbol is the decision making symbol. The symbol for decision making is as shown on the screen. This symbol is used to split the sequence of flowchart into multiple parts in order to represent selection and repetition. The arrows coming out of the decision box lead to different branches. For example, is A greater than B? There are two possible answers for this question, yes and no. And these two answers lead to two different branches. Each branch jumps to some part of the flowchart. Then we have a parallelogram or rhombus shape which denotes data entry or data display. This can be seen on the screen. You can use this symbol either to get the data from the user or print the data. That is the output from the program to the user. For instance, enter the number, display the sum, or the input and output operations. Next, we have connector. This basically connects one part of the flowchart to another part. Now, you may relate these symbols with the flowchart what we have shown for coffee making process. Before drawing the flowchart, let us understand how to draw a flowchart for a given problem. First, given a problem, we need to identify the inputs to be given by the user and the output to be produced from the flowchart, the logic to solve the given problem, and identify the appropriate symbols, and finally the sequence of steps to solve the problem. We will see how to use various flowchart symbols. As of right now, let us take an example of drawing a flowchart for finding total marks scored by a student in 2 courses. Before trying to draw the flowchart, let us find what is the input and what you want the output to be. The input is the marks scored by the students in 2 courses, and the output would be the total marks scored by the student. Then, what is the first block or symbol in the flowchart to be drawn? Yes, as you have guessed, it is the start symbol, which is always the first block of any flowchart. So, let us start with the start symbol. We have a start symbol, right? What are we going to do next? Well, the flowchart has to read the marks scored by the student in 2 courses. So, let us do that. What is the symbol used for reading? Yes, as you have guessed, it is a parallelogram as seen now. This shows the symbol which are used for getting input from the user. Here we get 2 inputs, namely mark 1 and mark 2. Next, what do? We need to add these 2 marks, say mark 1 and mark 2. For adding, we use processing symbol as seen here. This slide shows how to process, the symbol used for processing. So here the processing is to add 2 marks which we have just now read. Mark 1 and mark 2 are added and the result is placed in total. Then we need to display the result. For this, again we use output symbol, which is a parallelogram. So this is shown now, which shows the output to be produced from the flowchart, which is nothing but total in our example. Now, what is the next symbol? Of course, it is end. To end a flowchart, we use the terminator symbol, which shows a stop symbol which ends the flowchart. Now we have a complete flowchart that finds the total of the marks scored in 2 subjects. Please remember that any flowchart can have only one start and one stop. I hope you got it. In the previous example, we have explained a simple example for a flowchart that finds the total mark scored by a student in 2 courses. Suppose we want to find the average marks along with the total. Where do we need to do the changes? We need to add a process box because we are now calculating the average along with total. This is shown here. Here we have added one more processing, that is nothing but finding the average of the marks scored. So we have added an additional process box after finding the total, and we are printing both total and average marks scored by the student in two courses. In previous 2 examples, we have used mark 1, mark 2, total, AVG. What are they actually? They are variables. We have already explained about the variables. Anyway, let me brief about the variables. What do you really mean by a variable? A variable is something which can have a varying data. For example, mark 1 may hold 95 at some point of time in a flowchart and a different value at some point of time in the same flowchart. So, mark 1, mark 2, total and AVG are variables. The values of these variables may change at any point of time in the flowchart. So, the variables act as placeholders. Now, let us move on to the usage of decision box in the flowchart. When do we use the decision box in a flowchart? In our first real example of coffee making process, just think a while. Where could we add a decision box? See the flowchart. This slide shows coffee preparation with a choice whether black coffee or milk coffee is required. So as usual, we are getting the choice from the user whether he needs a black coffee or milk coffee. Then we are getting the required ingredients. Then we process as shown here. Heat the water, add coffee powder and sugar. Suppose if the choice is coffee with milk, we add milk and stir well. Suppose if the choice is a black coffee, we are not required to add milk, so we directly jump to stir well. So this is how a decision box is used. Then after stirring well, coffee is poured into the cup and it is ready to drink. Then finally we stop the flowchart. So where do we make the decision? If you are given a choice of black coffee or milk coffee, then you need to decide. The decision box leads to different paths based on the result of decision. Let us consider one more simple problem and draw the flowchart for its solution. Given the age of a person, say Jack, find whether Jack is eligible to vote or not. In this problem, the aim is to find whether the Jack is eligible to vote or not. What is the age to vote? In India, anyone who completes 18 years is eligible to vote. So now let us identify the input to be given for finding the solution. What is the input? It is the age of a person. Then we have to check whether the age is greater than or equal to 18 or not. The answer to the question is yes or no. If the answer is yes, then we can say the person is eligible to vote. Otherwise, he is not eligible. This decision taking step is represented by decision box in the flowchart. Now let us construct a flowchart for this problem. Watch the flowchart over the screen. So this slide shows how to draw a flowchart to find whether a person is eligible to vote or not. So as usual, we start with the terminator start and we are reading the age of a person and we are checking whether the person is greater than or equal to 18. That is, his age is greater than or equal to 18 using a decision box. If it is true, then he is eligible to vote. Otherwise, he is not eligible to vote. At last, whatever is the choice, finally, we end the flowchart with stop symbol. After the decision making, whichever decision is made, we need to stop the flowchart. This is a simple example for decision making process in a flowchart. Now let us draw one more flowchart using decision box. Given the height of two students in centimeters, you want to find the tallest student among them. Here comes the flowchart for this problem. Here we see a flowchart to find tallest student among two students in a class. So as usual, we start with start symbol, reading the height of student 1 and student 1 and student 2. Then we are comparing H1 with H2. If H1 is greater than H2, then student 1 is taller than student 2. Otherwise, student 2 is taller one. Then finally, we end the flowchart with stop symbol. So far, we have discussed decision box and explained its use in flowcharts. Now, it is the time to introduce loops. More often, we need to repeat something for a number of times. This is called a loop. Just recollect the flowchart of our real-life example of coffee making process. Is it possible to include any repetition in this process? Yes, of course. While preparing coffee, you would add sugar for sweetness. If it is not sweetened enough, you would add sugar and retest it. You would repeat this process till you feel enough sugar is added. The flowchart for this process is shown on the screen. So what you see on the screen is an example for repetitive structure. Again, we consider our good old example of coffee preparation. So as usual, we get the ingredient, everything. So here we use repetitive structure to find whether the coffee is sweetened enough. So we are tasting the coffee. If the sweetness is enough, we just add milk, stir well, and we continue like that. Suppose if the sugar is not enough, we add the sugar. We are again tasting it. Again we are checking whether the coffee is sweetened enough. If it is not so, then we add sugar. So we repeat this process till we feel that coffee is enough sugared. Then we are adding milk, stir well, pouring the coffee into the cup. Then the coffee is ready to drink. Then finally we stop. Recall the flowchart we created for finding the total marks scored in 2 courses. Having seen a real life example for looping, let us now get into an example of finding total marks scored in n courses. Let me show the flowchart first and explain it. This is a flowchart to find total marks scored by a student in n subjects. Again, this is an example of repetitive structure. So as usual, we read n. Here the purpose of reading n is to find the number of courses for which we want to find the sum. Then we initialize total and count to 0. The initialization is must, otherwise they will contain some garbage value which will lead to incorrect total and count. So we initialize them to 0. Then we are checking whether the count is reached n. That means we have some more number, that is some more marks to be added or not. If count is less than n, then we read the mark and we are finding the running total by adding total with mark. Then we are incrementing the count by 1. So this count is incremented to keep how many times we have repeated so far. Then again we are checking whether count is less than or equal to n. If it is so, we repeat the process of getting marks, adding them with the total, then count, incrementing count. If the count is reached n, then we stop. That means we have finished adding of n marks. Then we say what is the total. Finally, we stop the flowchart. In this flowchart, we use a variable named total, which is initialized to 0. An uninitialized variable as a random value, that is garbage value, but not 0. So when we add something to this uninitialized variable, it will give a wrong answer. Hence it is necessary to initialize the variables. Then we read n, which is the number of courses for which we would like to add the marks. We again use a variable count initialized to 0. If you don't initialize that count to 0, then it will automatically assign some random number. This may lead to repetition incorrect number of times, that is not n times. Next, we have a decision box to control the number of times the process of adding to be repeated. The loop is to be repeated for n times. Here n is the number of courses, and for these many number of courses we want to find the total of the scored marks. So we have count variable to control the loop. Here we check whether count has reached n. If it is not so, that means the loop has to be repeated. Otherwise, there is no need to repeat. Inside the loop, we read the marks to be added. We read the marks in course 1 in the variable mark. Next, we add the value of mark to the current value of total and update the total to the new value. Suppose at first the value of total is 0 and the mark is 89, then mark is added to the current value of total, which is 0, and the result 89 is placed in total, and then count is incremented by 1. This is done to keep how many times so far the looping statements have been executed. Initially the count is 0 and first time after the loop it will be 1. Again count is checked against n. If its value is less than n, then next number is read, updated with total, and count is incremented in each iteration. If the count reaches n, then the value of the total is printed as result. The iteration continues for n times. That's it, learners. That is all about the loop. We have many other problems to show you in the next module. Now let us enumerate the guidelines to be followed while drawing a flowchart. First one is all necessary requirements should be listed in logical order. Then the flowchart should be clear, neat and easy to follow. There should not be any ambiguity in understanding the flowchart. Next is the usual direction of the flowchart of a procedure or a system is from left to right or top to bottom. Finally, only one flow line should come out from a process symbol. Only one flow line should enter a decision symbol and 2 lines come out of the decision symbol, each representing true and false. If the flowchart becomes complex, it is better to use connector symbols to reduce the number of flow lines. Avoid the intersection of flow lines if you want to make it more effective and better way of communication. It is necessary to ensure that the flowchart has a logical start and end. It is useful to test the validity of the flowchart by passing it through with a simple test data. Having enumerated the guidelines, let me list the benefits of flowchart. A flowchart makes logic clear. It provides easy understanding and effective analysis of the logic. It is useful in coding and enables proper testing and debugging. Before closing, let me summarize what we have learnt in this module. In this module, we learnt flowchart, a graphical tool that helps in providing logic for solving a problem. And also we outlined the 3 ways of structuring the logic. Meet you soon in the next module on Raptor, a flowcharting tool. I hope you have enjoyed learning flowchart. Thank you.